let's do a little bit of a rundown on what the issue was. It had to do with the flat earthers not understanding what gravity is. Essentially, that's what it comes down to. Okay, so here's flat Earth and gravity. Okay, and they say it's density, they say it's inertia, and they use all these concepts. And we don't want concepts. We want to know what physical object prevents an atom from moving. That's essentially the issue. So let's start at square zero. Okay, we're going to go with a first frame of the film. Okay, here it is. We have a van, okay, and we have a particle. We're going to call that an oxygen atom, or we can call it a molecule. I'll use the word molecule, okay? So that red little dot there, that's a molecule of air. Okay, think of it as that, as a single particle, period. Okay, so we have the van and it's standing still, it's parked, okay? And now this van is going to move, okay? So it's going to move, and the question, what happens to that particle? Turns out the particle stays in the same place. And the particles that are close to the back of the van, those are going to be pushed by the back of the van. But that particle, the one that's still up front, that particle is not moving. So when the van moves, okay, the particle stays. You see what happened there? Okay, let me do that again. Here's the particle. Okay, just watch the particle and you watch that. As the van accelerates, the particle stays in place. We got that so far? Okay. Flat earthers, all these people, they have a lot of problems with that. Okay. So it stays in place. And the question is, what caused it to stay in place? And here we are 6 weeks later, and still they can't understand the question. They can't understand the question. Obviously, they won't have an answer, right? Okay, so here we have it. Gall says, these are some of the answers I got. It shows you that they don't understand the question. And I like this fellow. Yeah, he went in there and he says, I went to school. Okay, that's great. I'm glad you told us that, okay, that you went to school. Apparently, he went to a $30,000 a year Royal Naval private boarding school. My God. Okay, he must be a genius. Okay. And this flat earther says the space in between those balls are a deceptive misnomer. Non-physical empty spaces have never been physically proven to exist. He's saying that space does not exist. There's no separation between objects. There are, it's object against object. That's what he thinks it is. Ball against ball, cube against cube, whatever. Empty space is literally nonsense. And this guy went to what? He went to school, okay, and $30,000 a year Royal Navy private boarding school. All I can say is, please, guy, go sue that school and tell them that they gypped you. They took away, your money for it. At least try to recover, your whatever money you invested in there. They are only a mathematical construct of the perfect vacuum of space. You are touting non-physical pseudoscience concepts which have never been experimentally verified, even with the best vacuum chamber on Earth. So this poor little fellow, he believes that you have to prove the existence of space, otherwise it doesn't exist. And again, it has to do with all these people who talk about proof, evidence, experiments, testing, verifying. None of that has anything to do with science. In science, we do not test, we do not do experiments, we do not verify anything. Okay, in science, we explain. You have to get in the ring, be a boxer. You have to fight. You're not the critic who's sitting in the audience and saying, well, you should have hit him with a left hand, with a right hand, and whatever. No, the way it works in science, you have to be a boxer. That's a scientist, the guy who's up there in the ring, putting forth a theory and defending it. Okay, and so this guy talks about verifying. That's religion. Verifying is religion. Evidence is religion. Evidence is what a prosecutor uses to persuade the jury. That's called evidence, and that's got to do with persuading, which has nothing to do with science at all. It's got to do with religion. We do not prove in science, especially we do not prove the existence of space. Good luck with that one. Okay? Prove the existence of nothing. Yeah, it's easy. Okay, so what is the issue? Well, he says you are avoiding the fact that there is no gap between the molecules in reality. There are molecules throughout, like the structure of the atmosphere. Unless you can explain what your gaps are, why the molecules are not already touching each other, they are composited from various sized molecules, which you are completely avoiding. Okay, says I have only ever been dealing with 100% physics of molecules touching molecules in a fluid sense and then touching a physical structure of glass molecules. Okay, structure of a physical car and structure of physical molecules of the atmosphere is the only mechanism available to you in reality. He's talking about the fact that the car pushes the molecules and the molecules, are all pushing on each other. So he's saying that the molecule is really that I'm talking about, the one that I'm saying stand still. He says it stands still because it's got all these molecules not only underneath it, but all around it that keep it in place. That's what holds it in place. That's what he's referring to, okay? If you deconstruct the atmosphere, adding gaps everywhere, then there would be an immediately automatic adjustment to fill those imaginary gaps you added with molecules. It's like swimming in a ball pit with various sized balls, and the big ones and small ones all support each other. So this fellow says there's no such thing as space. Okay, that he's got this notion that they had in the old days, in the days of the Greeks, where as soon as you had Aristotle believed in that as well. That if you move a molecule, another one takes its place immediately. So there is no such thing as space because it doesn't allow for there to be a space. As soon as one moves, another one takes its place. It could be an oxygen molecule, could be a water molecule, could be a molecule of a table or whatever object, immediately takes that space. So there's no such thing as empty space according to this fellow, which was what Aristotle said a long time ago. Okay, this is what he's got. He's resuscitated poor old Aristotle. Okay, so let's zoom in, okay, on that little picture he had there, okay? And there you see the molecules. We're going to consider them as perfectly round, okay? They're not even that, okay? But assuming they're round, we want to know what the white stuff is, okay? What is that white stuff that separates one molecule, that contours each molecule, each atom, if you will? What is the white stuff? That's the million-dollar question. If you say there is no such thing as space, which serves as a backdrop to every single object in the universe, tell me what does. What do you call that thing that separates table from chair, or molecule from molecule, or atom from atom? What is that stuff? What is the white stuff? That's what we wish to understand. We want you to identify the white stuff, okay? And so if you have cubes, same thing. I mean, you might say, well, they're face to face, they're surface to surface. You got to tell me what separates each cube. Otherwise, that would be a single block of matter. The universe would be a single block. Okay, so hopefully, if you have little particles and they're squarish like that, cubic-like, well, then you have to tell me what separates one cube from another. If not space, what is that stuff that separates one cube from another? You have to identify that. And this fellow doesn't believe in space, but he doesn't tell us what he proposes instead. Okay, that's where we have a problem. Okay, but he continues and he says the following. He says, what is making a single oxygen molecule stay in location until the window hits it and drags it along? Yeah, that's the question. We want to understand that question. Do you understand the question? And he doesn't, because he has the structure of the atmosphere. Okay, let's see what he's got in mind. There are other molecules radially in all directions providing resistance and support to this single isolated molecule. So he says the molecule is surrounded by gazillions of molecules. So if this is the molecule, right, he's got all these molecules all around it that hold it in place. That's what he's saying, okay, more or less, because obviously there is some motion, but in general it doesn't move as fast as the molecules which are hit by the glass in the back of the van. Those molecules are moving faster because suddenly the car hit them or struck them or came up against them. The molecules that still have not been touched by the glass, they're standing still right now. And he's saying they're held together, held in place, in that place, by all the other molecules in the car. That's what he's saying, okay? Keep that in mind. Without a structure of the atmosphere with molecules surrounding this isolated molecule, it would naturally fall down, as it would have no supportive medium of an equal or greater density beneath it. Okay, he's talking about beneath. He hasn't mentioned anything about the side. And then he makes it even worse for himself. He says, 5 weeks of me repeating the exact same thing. Yeah, this is now the 6th week, and still he hasn't understood the question. Let me show you what the problem is with him understanding the question. If Eddie says, as he's saying, that the molecule of air, right, or atom of oxygen, it doesn't really matter, is being held by all the other molecules of air, okay, well, then we would have this situation, and I only drew a few of them there, okay? It would be held together in place, like he says, by all the ones that are sitting on the bottom of the van and those that are hitting already in contact with the back of the van. So these molecules are not sitting exactly standing still. They're all moving around, but relatively in their own region, okay? They're not moving widely in the van until the van accelerates, okay? Now we're going to accelerate the van, but see, if all these molecules are what hold the red molecule in place, then when the van moves, it's going to take them with them, all of them. It's going to take the red molecule as well if it's, like he says, that all these molecules hold it in place. It's the same situation that I had the other day with the pencil. If you put a pencil, because it's solid, well, yeah, the van's going to push the whole pencil, every molecule of the pencil. And here we have the same situation. Here you have it standing still. He's saying the molecules are holding it in place. And when the van moves, it should move all the molecules at the same time. This is not what is happening. Okay? This is not what is happening. What is happening is that that molecule stays in place while the other molecules are moving. What is happening is this. Let me show it to you. Okay, this is what is happening. Okay, let's see it in motion here. Okay, here we have a tree. Okay, and we have the van moving all the atoms at the same time. This is what he's saying, that the molecule is being held in place by all the other molecules. Well, then they should all move together, and this is not what we see. What we see is that little red molecule stays in place while the others are moving. What we see is this, essentially. Here it is, okay? You see that it's moving one group of molecules at a time while the others stay in their place. Okay, you see what's happening here? It's not that they all move at the same time, all the molecules of air. No, some are moving while the other ones are standing still. And here, let me freeze one frame so that I can make my point. This is what we're seeing. Okay, we're seeing that a molecule, the van is pushing the molecules in the back to which it's in contact with, okay? And those are moving the other molecules, but meanwhile, you have all these other molecules which are more or less standing still in the same region, waiting for something to push them forward. Okay, that's the situation. And this all doesn't understand that. He says, oh, the molecules are held in place by all the other molecules. Well, if that were the case, then they would all move, as a single group. Okay, and that's not what we see, or that's not the theory, at least. He might have a different theory. He's got to put it out there. Okay, so this is the issue. Okay, so let's go slowly here. Here we have a fellow who says, just added that, says, whoever said the air in the car was standing still, everything on the planet is moving at hundreds of thousands of miles per hour with respect to the center of the galaxy. Motion is always relative. Again, this guy is completely out of whack. He doesn't understand what the context is. The context is all molecules are moving. No one is saying that they stand completely still, especially air. Okay, so they're moving, but some molecules are moving faster than other molecules. Why? Because the van is pushing those molecules, and those molecules are pushing others and others and others down the line as the van accelerates. But until the van pushes the molecules which push the other molecules, some molecules are standing still, waiting for the other molecules to be squashed together and push them forward. That's what's happening. Meanwhile, these molecules are more or less standing still in the same region, waiting for something to push them. This is what these people don't understand. So we got to go very slowly here, because they 6 weeks, they still don't understand the question. They don't understand what they're supposed to answer. And obviously, if they don't understand what they're supposed to answer, they can't answer the question, which explains in large measure why no one has been able to explain gravity in mathematical physics. All these are flat earthers, all of them, from mathematical physics all the way to the last guy in the flat world. Okay, so here it is. Let's go slowly. What did I do the other day? I think a couple of weeks ago. We have a tree. And we built the van on top of the tree. By mistake, by design, we don't care. Okay, the point is, we built the van, or the van is parked on top of a tree somehow. The tree grew underneath it. Okay, that's the situation. So the tree is stuck to the ground, whereas the molecule of air is not stuck to the ground. Neither one is touching the van. Neither the tree is touching the van, any part of the van, neither the molecule. The only difference between the molecule, I mean, they're both inside the van, but the difference between the molecule and the tree is stuck to the ground, obviously, whereas the molecule apparently is not. Okay, that's what we have in front of our eyes. Okay, we understand that so far? Now the van's going to accelerate. What's going to happen to the tree? What's going to happen to the molecule? Well, hopefully the tree remains behind, right? But does the molecule remain behind? The answer is yes, the molecule also remains behind. Here it is. Okay, so here it is again. Okay, this is where we were. And now the van moves forward, the tree stays behind, and the molecule stays behind. So we asked the people, we said, well, why did the tree stay behind? And people say, well, because it's stuck to the ground. That's why. It's not touching any part of the car, but it stayed behind because it's stuck to the ground. Okay, so we all pretty much understand that, right? The question is, why did the molecule stay behind? What is it stuck to? And here people say, well, the issue here is that there is no force that came up against the molecule. That was not the answer they gave to the tree. They didn't say there's no force that pushed the tree. They say the tree is stuck to the ground. That's why it didn't move. They didn't talk about force there. But now they're saying a force did not touch the molecule. That's the answer they give you. Everybody gives you that answer. The first problem is the word force is not a physical object. Okay, so you can't say that a force did not push or pull on the molecule. You can say a horse did. Maybe that's what they meant. You can say a horse did not push on the molecule or pull on the molecule. You can say a car, a tree, a chair, a rock. You can say any of those physical objects did not push the molecule, but you cannot say a force, because a force is a concept. Okay, so the people who fed them this language, force, were the mathematicians, and that's the language these people use to try to communicate their ideas. And so they say a force did not move it. Okay, so we can't say a force. You can say that a paddle did not hit that molecule. Then we all understand it. Okay, paddle is a physical object. Okay, so we have that situation where the tree stays behind, the molecule also stayed behind. You say, well, I understand why. The reason it's stay behind is the tree is stuck to the ground, the molecule is not. No force came and pushed the molecule. That's the answer they give you. Okay, let's do it differently. Let's do the experiment a little differently so that we get to the bottom of this thing. Little by little, 7 weeks, 8 weeks, we'll get to the bottom of this. Okay, so here we're going to build the van this time on top of a different kind of tree. The tree is just lying down there, or maybe the van just parked there on top of the tree. Okay, so that's the situation. It just parked there. So we have the tree, and it's not stuck to the ground now. It's also inside the van, most of it, like the particle is. What's going to happen when we accelerate the van? What's going to happen to the tree, which is no longer stuck to the ground? What's going to happen to the particle, which is not apparently stuck to the ground? Okay, that's what we want to find out. Well, more or less, this is what probably is going to happen. The van is going to advance, and the tree is also going to remain behind together with a molecule. And so now why did the tree stay behind? And you can't say it's because it's stuck to the ground. So what are you going to say? Are you going to say that no force moved the tree? Is that the answer you're going to give? There was no force until the van hit it. Until then, no force hit it. So is that why the tree did not move? See, before the answer was it stuck to the ground. Now the answer is, well, a force did not move the tree. What do you mean a force? What force kept it there? That's the question. And this is where people have a problem, because they don't realize that you require a force to keep it there. Okay, just like you require a force to keep the molecule there. Both require something to keep it there. And that's something Newton and Galileo and all these other people never discovered. They said, well, a particle moves, or a thing moves, a mass moves, right? As long as something doesn't stop it or changes its course. That was the idea that they had. Well, what about something standing still? Doesn't it require something, a physical entity, to keep it there until a horse, right, moves it, until a thing comes in contact with it and moves it? Don't you require something to keep it there? Yeah, it's known as gravity. See, it's gravity that kept the tree there underneath the car. When the car moved, it's gravity, whatever gravity is, right? Density, mass, inertia, whatever word you want to put in there. That's what kept it there. That's what kept the tree there. And it's the same thing that keeps the molecule there, even if it was the only molecule in the entire car. Okay, so we have the molecule and we have the tree, and they're all both standing there because something known as gravity, inertia, whatever you want to call it, kept it there. What we need to answer is, what is gravity? What is inertia? What physical thing mediates gravity? That's the question that you have to answer. And people say, well, no, until a force hits it. No, forget about that. We don't care about that. We want to know what kept it there. And you can't say a force kept it there, the force of gravity, because that's what we want to answer. We want to say, what is the force of gravity? What mediates the force of gravity that kept the tree and the molecule staying there until the van hit them and moved them? That's the question. Okay? And so, yeah, we do have an answer. Obviously, here it is. It's that what keeps the molecule in place is that the molecule is bound to every atom on Earth. Every atom on Earth is bound to that molecule. So even though it has some movement, yes, it does move, it moves very little until the van accumulates all these particles and pushes them all forward when it accelerates. Okay? So the molecule is pretty much standing in the same region until something hits it. Why is it standing in the same region? Because it is bound to every atom on Earth. Every atom on Earth is bound to it. And you say, Bill, that's nonsense. I don't see anything. So there's nothing there. What do you mean it's bound to every atom on Earth? And once again, I got to pull Mr. Muller out. Professor Muller from Berkeley, and people may be sick of hearing him, but I'm going to put him one more time because all these people are so ignorant that they are not listening again. They should listen to Mr. Muller. Here he goes. Listen carefully, okay? Here he goes.
What's the force of gravity on me? It's the pull of the Earth on my body. So, for example, if you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it.
Okay? So you're pulling on it, and everything is pulling on you. Did you understand that? Apparently, some people still don't understand what that. And nobody, I know people don't understand because no one even raised the issue. Here I'm putting that on there. Nobody commented on that. Not a single flat earther. See, if they would have commented and say, look, I don't agree, or for this and this and reason, they made a case, no one even addressed the issue. So I put it on there. They're listening to it, but it's like everybody skirts it, goes around it, goes way around it. They don't want to address that issue. And so all I can do is show you one more time. Tonight, when you go to bed, please say the Lord's Prayer, the Lord Bill's Prayer. Okay, here it is. Every atom on earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay, if you can understand that, you have understood gravity, the cause of gravity. And the other thing that you've got to understand about that is that since we can't see or touch whatever is connecting you to every atom on earth, then you have to conclude that the mediator is invisible and intangible. It's known as noumena. You have phenomena and noumena. Noumena are things that are of the mind. You can only visualize them. You can conceptualize them. Say, look, this is probably how Mother Nature does her things with invisible, intangible things, things that we cannot see or touch. But that's the way we can explain gravity. Otherwise, you have to say action at a distance, and that is known as black magic.